Welcome to Classes Part 2. In the previous video, Classes Part 1, which comes from my book, Computer Scripting Techniques with Python, Chapter 17, Introduction to Classes and Object-Oriented Programming. I discussed the fundamentals of classes, the rationale for why you'd want to use classes, what is a class, what the word class means in different contexts, such as analysis and design, and how the language has to support the class keyword if you're going to create classes. Okay, what is an object? An object is really just a region in memory. When you have a class, you define the class, you're defining a new type. And with that new type, you can create instances of that type, as many instances as you need for your application. So then in that previous video, again, this is really just a recap of that previous video. I showed you how to define a class, what the purpose of the underscore new special method was. That is actually the constructor. And then underscore init, that's the initializer. You don't see the new, right? So I also discussed that the new special method, the constructor, is not always necessary. And in fact, generally, you don't use it unless you need, under very special circumstances, to control the creation of your new objects, right? Otherwise, you could just use the one that's provided by default. The init, the underscore or dunder underscore init, dunder init method, special method, right, is really once the object is created, you initialize your class to a known state. That's the important part. You want to initialize these objects to a known state. Okay, so in this case, we're initializing the person object with first name, middle name, last name. If you just created an instance of this object with and passed in no arguments for first name, then John J. Doe are the default arguments for first name, middle name, and last name. And that's how your object would come into existence. This count on line 8, that count attribute there, it belongs to person. It doesn't belong to a particular object. It belongs to all objects, right? Because it's a class-wide, or I guess you could say static attribute, and has to be handled. You have to access that differently, right? So person.count. Now, if by mistake in the code someplace you accessed self dot count, then you would create a new attribute for that particular object that you made that mistake on, right? And the other objects wouldn't have that instance attribute. So that's the one downside about Python. It's kind of crazy, but you have to have discipline. I think that's a very important aspect of being a programmer, is you have to discipline yourself not to do crazy shit in your code, right? So then I went through the main module, how to instantiate these objects and how you can access the properties directly. And yes, this is the preferred way of doing it in Python, where you just declare your attributes, right? Like self.firstname, self.middlename, and then you access them directly, right? That is perfectly fine. That would, like I said in that earlier video, that would drive a C++ and a Java and a C# programmer insane to directly access an instance variable or attribute without going through some type of property, right? The properties have their place. We'll talk about that in this video. To new or not to new, like I said, the new underscore new method is the constructor, and you do not usually need to implement the constructor, but generally always want to implement the initializer. And for your sanity, I didn't go over these last time, so rules to preserve your sanity, right, when you're dealing with classes. One class per module. Don't define multiple classes. Name your module, like for example, person, .py, lowercase, right? And here we have it right here. Person.py is the module, contains the class definition for person, capital P, P-E-R-S-O-N, right? One class per person. That way, when you have a complex project, you look at your modules and you go, my person class or my whatever class is in that module right there. You don't have to guess or search. Access class-wide attributes via the class name, right? So person.count, make sure you always, if it's a class-wide attribute, access it with the class name. Access instance attributes via reference name, like P1 for first name, P2 for first name, whatever. These are references to actual objects in memory, all right? And then that's how you access the instance attributes. Instantiate objects in a known state. That's the purpose of an initializer method. So always implement an initializer method. There's probably some instances, perhaps with data classes, where you don't necessarily need to implement the initializer method, but I've always done that, right? So it just something to do. Now, preserve good code naming conventions, right? Module names should be lowercase with underscores separating each word. This comes from PEP 8, essentially. And observe good class naming conventions. Class names should begin with an uppercase character letter, with the first letter of each subsequent word in multi-word class names capitalized. This is called Pascal case. So snake case for the module names, Pascal case for the class names. Again, I think this comes from PEP 8. And again, just to stamp my foot, one class per module helps tame both conceptual and physical complexity. And I just want to say, right, when I was learning how to program C and C Sharp or C++, right, there's this great book called Enough Rope to Shoot Yourself in the Foot. It's a must read for anybody learning C or C++. I love that book. And essentially it just says, just because a programming language allows you to do something doesn't mean that you should. And Python is very powerful. It's flexible. And like C and C++, you can do things in Python that can lead to disaster if you're not fully aware of the consequences. Okay. And I'm going to make a slight revision to example 17.2 to illustrate my point. So at this point, I think I'm going to switch. Well, okay, so yeah, right here. In the main, right, we're creating these instances. So we have p1.count. We can access the class-wide person attribute with the instance, right? We can access it with the instance, and that will access the person count. But if we set p1 count, right, then we've made a mistake, because now we've created a new attribute in p1, which is not, it's not going to be the same, right? So let me go run this code. So let me switch over to my, to this project. All right, so cd dev/dev.books cd cst with Python, cls, dir, cd, chapter 17, I think. All right, so cls, person, project rev1. Okay, so I think it's person project rev1. Rev1. Let's just open up Visual Studio Code here and see what the dealio is. All right, let me adjust this to fit in my window. All right, close this AI thing. Give me some more screen space. Main. I'm really talking about the main here. Okay, so we have. Let me make the text bigger. That should be fine. So this code is pretty much the same, right? Let's go back to the book just to verify. So I'm going to go back to the book. I'm going to go back up to this one here. So, okay. So I'm accessing person count. This is the preferred way, right? Person count. That's how you access and set a person class-wide attribute. But you can access the class-wide attribute via, you can access, and I'm saying access, foot stomp access, you can access a class-wide attribute via the instance reference. All right. So let's go back to Visual Studio Code. So this is fine, right? It's you just got to make sure that you're not setting it. That will give you the consistent value of whatever that class constant or that class reference attribute, excuse me. But as soon as you set p1.count equals 100, you're not accessing the class attribute. You've created a new attribute for P1, and P2 and P3 don't have that same attribute, right? There, if you're accessing P2.count, it's accessing person.count. And P3.count is actually accessing person.count. But now that you set P1.count to 100, P1.count is a whole new attribute in the P1 object. Okay, that is the crazy part. So let's run this code, and I'll show you what the effects are. So clear the screen. Python 3 main. So we got object count 1, right? Object count 2, object count 3. And then in the code, we set P1 equals 100. And then we access P1 dot count, and it's 100. But it's not 100 in P2 or P3 because P2 and P3 are referencing or accessing the person.count, right? This is an important concept to wrap your head around because this is because, like I said, right, this goes back to what I was saying about shooting yourself in the foot, like that book with the C and C++, right? Python is flexible. Python is powerful. And Python will let you do stuff that will make you wish you hadn't done it, right? So just be aware. Be aware of that. All right. So with that out of the way, let's go into some more attributes versus properties. Attributes versus properties, or as I've written it here in the title, properties versus attributes. Again, I'd like to emphasize that if you're coming from another language like Java, C# or C++ that support private fields and the notion of data encapsulation, this seems strange, and it seemed strange to me at first until I realized, oh, okay, yeah, I can live with this, right? So all class instance attributes are publicly accessible. That's the first thing you got to realize, right? Like there is no such thing as encapsulation in Python, right? There is a convention in Python, which is discussed in PEP 8, that instructs you to prefix an underscore to an attribute to serve as a signal to clients not to access that attribute directly, right? And we've talked about this before, especially in the context of functions in modules, right? So that same underscore acts as the signal for attributes as well. So in this example, I'm going to add a date, okay? And I'm going to say that this is, don't access this directly because I want to actually have a birthday property, okay? So let's go to the code. Let's go back to the code. And let's go up here, up one. Oh, actually, let me go here. Visual Studio Code. I'm going to close this one down. CD dir cd person properties.
option. BMW Properties General Contractor on Pennsylvania Avenue in Falls Church.
Shut up, Siri.
Okay.
Siri is crazy, man. Like, she listens to what you're saying, and then she just starts talking to you. Anyway, I have to tell her to shut up every once in a while. Okay, so person properties code dot, and here we are. All right, so let me shut this one down. Let me squeeze this. Give me more real estate space. So in the person, so here's what we're doing in this one. We have a, we can create, obviously these are instance attributes, self.firstname, self.middle name, self.last name. Now we have, I created a new one here called self.underscore date of birth, or DOB, right? So I've added a new parameter to the initialization method, or the underscore in it. So date of birth equals date time object or type equals datetime.now. All right. So I'm just, when it comes in, this is just the default value, right? So also too, I had to import from datetime, import the date and import datetime. Now I've got this self underscore DOB, and the underscore says do not access this directly. And I assign the date of birth parameter to that attribute. Okay. Then I use the property keyword. That's the @ property, and I define a property. Now this definition looks a lot like a method. So property birthday. Okay. So I guess you could say this is like an or getter method, or an accessor method, right, in other languages. Property, and properties in C#. And then you have the self keyword. And what this does is just returns the date of birth, underscore DOB, right? So we are authorized to access, we can get the value of the date of birth, but we don't want to access underscore DOB directly from client classes. We want to use the birthday property, and it's going to give us the date of birth, right, value. Now we have a setter. If we want to set that, we have to create a setter. And the way that we do that is we say, here's the property birthday. Now we want to create a birthday setter. And so we say def birthday, self value date time, and then it returns none. And then we're setting the self dot underscore DOB with the value. Now you just have to write this in engineer's notebook, right? So you declare the property with the @ property. This is a decorator, I think it is. And then you use @ birthday dot setter to create, if you want to set the property, right? And then here's another property called full name. So if I want the full name, I create another property called full name. And in this particular case, this is just a read-only property, all right? Because there is no setter for full name. So full name returns a formatted string that strings together a self.firstname, self.middlename, self.lastname. And that's a good way to do it, all right? Now here's another property called age. So today, datetime.now, date, b day equals today, date.year, self, birthday.day, and then adjust, right, blah, 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 return today, adjustment, right? So now full name, so here's another property, full name and age. So now I'm returning the full name and age. So I have created several properties. Most importantly, I created a birthday and a birthday setter. And then I created a read-only property. So I guess you could say this is a read-write. Together, this is a read-write for the birthday. All right. A read-only for the full name, a read-only for the age, and a read-only for full name and age. And then Lastly, for the special method dunder string, str, I return the string representation self, full name, and age. So it's returning this property, full name and age, right? That property right there. Sorry. So it's returning that property right there. All right, let's see this code run. So we go to main and we create a default object, right? It's got John J. Doe. We access the person count. Then we create Rick Miller with the birthday. And then we print the age of P2. And then we print the P2 in this will cause the string, the underscore string representation, and that will print full name and age. And then person P3 is Hannah J. Banana, and we set her birthday, and then we print the full name and age. And okay, so let's run this code and see what it looks like. So we go back to here, and I'm going to clear the screen. Python 3 main.py. Okay, so that's one of the beautiful things about having a main, right, is you know what to run. So main.py runs it, and we say the initialize method is called, right? John J. Doe, and because today's date is the birthday, his age is 0, and then we got John J. Doe, and then we got another initializer, and this is for Rick W. Miller, right? So age 40, Rick W. Miller, object count 2, and then another initializer, another object is created. Hannah J. Banana, 32, full name and age, Hannah J. Banana, 32, right? So this just shows that the full name and age is, prints the same information as the string representation because it's called in the same property. Let's talk more about methods. A method is a function that is defined within a class. You learned about functions in Chapter 12, modules and functions. So here I shall only focus on how to define and call methods. You've already kind of seen this done. Everything you learn about functions with regards to defining parameters, passing in arguments, and returning values applies to methods as well. However, before diving into the meat of this section, I want to briefly discuss the special methods and properties of the person class listed in example 17.4. So, as you learned earlier, the person class defines two special methods. Init, right, which is the initializer. It's double underscore. These are special methods. This is the initializer. And the double underscore str. This is the string representation of this class. There's another one called RPR for representation, and I'll talk about that, I think, here in a second. So the purpose of these special methods is to customize the object behavior with regards to how they are used with various language operators. In the case of the person class, I am at this point only interested in customizing object initialization with the init method and custom string representation with the string special method, str, right? The init method is implicitly called when a person instance is created, as shown in the following code snippet. P1 equals person, right? The string, or the double underscore string method, is implicitly called when a person object is passed as an argument to the built-in print function, like so. So you can just send it into print, right? Note, you are technically not required to implement either of these methods, but it is considered best practice to do so. If you do not provide an implementation for the initialization method, you'll need to write additional code to define instance attributes. The default implementation of the string method, or str, returns information about an object's memory and location. For example, removing the string definition from person class results in the following output when I call print P1, right? If you try this at home, right, then you're going to get a different memory location on your computer. All right, so let's run this, right, and I'll show you what I'm talking about. So I'm going to go back up here, and I'm just going to go to Visual Studio Code. I'm going to go to the previous example that we worked on. I'm going to go to person, and I'm just going to comment out the str, right? So I'm just going to go edit. You don't see this. It's kind of offline. So toggle a block comment. So I'm just commenting out this whole thing. Oh, I'm sorry. I can't do that. Let's do this again. I have to do it line by line. Edit. Toggle block comment. Okay. So I'm going to do this. There we go. So I've commented out the double underscore string, and now I'm going to run this code. CLS and Python 3 main.py. So without that string representation, if P1 just gives the objects, so person object at and its location in memory, right? That's what the string representation special method does by default, right? So if you don't, it's a convenience thing to do, right? So every time I create a class, I implement a double underscore string because I want to see like what my class data contains usually, right? Not necessarily the address that it's at. Okay, so I'll go back to Visual Studio Code, and I'm going to uncomment this out. All right. Save, and then run the code again. CLS. And we're back to where we were, right? So that's the behavior that I want right there. I want it to give the full name and age. All right. So special, now there's a lot of special methods, and special methods are Python's way of allowing operator overloading. And I'll talk more about this in another video. But it's covered in Chapter 19, Well-Behaved Objects. Okay, so now property definitions. Referring again to the person class, the property definitions look suspiciously like method definitions, but the property decorator changes the semantics. By this I mean you access properties like attributes as opposed to calling them like a method, right? So now, defining and calling a method is defined within the body of a class definition. A method defines at least one parameter, self, which is a reference to the instance to the object. So the parameter name self is strictly a convention. You could use any name, but I recommend sticking with self, as all documentation and examples on the internet use self. So just use self, right? The biggest problem you'll face when starting to create your own classes and methods is forgetting to add the parameter self to your methods and then wondering why things don't work, right? So to inject some fun into this conversation, I'm going to add the capability to associate person objects with family relationships. So in this graph here, I'm going to create like these are person objects, right? The family relationship graph. So me, I have a child. His name is Kyle. Kyle has a parent, a father named Rick. Corey Lee has a son. She has a child. He's a son. Kyle has a parent. It's a mother. Corey Lee. Kyle has an aunt, Katrina. Kyle has an aunt, a nephew. Lois. And Lois is a grand aunt, right? Kyle is his grand nephew, and Kyle is Katrina's nephew. Anyway, you see the relationships there, right? The graph consists of nodes, vertices represented by circles, and edges represented by the lines connecting each node. This is a directed graph in that the edges have an arrow that indicates the direction of the relationship, right? So to store a person's relationship, I will add a dictionary to the person class, along with several methods to add and show a person's relationships. So let's go to the code. I'm going to walk through the code and then run it and then walk through the code again. So let's just change here. So first off, let me shut down Visual Studio Code and then go to that project. CD, CD relationships. All right, so CODE dot. Now, close that, shrink this down, and we'll look at person. And we'll go, so in the person class, I have the date of birth attribute. I have the regular, everything's there from the previous person example. I have the self underscore date of birth. I have the same properties that were done before. Now I've added this underscore relationships dictionary to the class. So now I have a method down here called add relationship. Okay. So define how you define a method, add relationship. Okay. Self, you've got to remember. And then P any stands for any type, right? P could be anything. Relationship is a string, and then add relationship to P. So if relationship is not in self relationships, so we're going to go, hey, is this relationship in there already? Then create relationships, right? And it's going to say self relationships, relationship, whatever that relationship is going to be a new array. Okay. So now I've just got some various relationships. This is not meant to be a catch-all, right? So match relationship, case, parent, father, mother, sibling, brother, sister, child, daughter, son, aunt, uncle, niece, nephew, grand aunt, right? So if is instance P person, so in other words, if I'm passing in a person object, if this P is not already in self relationships, then add the person to this relationship. All right. Case, it's not in this, it in the one of these relationships, then go ahead and add it anyway. Right. I guess I just gave up the ghost on that one. And then show relationships. So def show relationships. In this case, there is no other parameters, but you always have to have the self parameter. So this is another method. So for key in self relationships, for entry in self relationships key, right? Print self full name key entry. So let's run this, right? And this code will make a lot more sense. So we're going to run this program. Well, maybe we should see main, what the main looks like, right? Let's take a look at the main. So main. All right, so here I'm importing person and date time. So I create person objects. I create Rick, Kyle, Rick, Corey, Lee, Katrina, Lois, right? And then print the information for each one of these objects. And then I add a relationship. So, for example, Kyle, add relationship, Rick, parent. So I'm adding this object, right, Rick, as the parent. Okay. Add relationship, Rick, father. So there'll be like two parent relationships. I got, then I'm going to have the father. I'll be added to the father relationship. And then for me, Rick, add relationship, Kyle, child. add relationship Kyle's son. Kyle, add relationship Corey Lee parent, add relationship Corey Lee mother. Corey Lee, add relationship son. You get the point, right? I'm adding these relationships. And then Kyle, show relationships. Rick, show relationships. All right, so let's run this program to see what this is doing. I have no idea if this is a practical way of doing this, right? It was just kind of fun to do the project. So Python 3 main.py. So there we go. So Kyle Victor Miller, 9, object count 5, Rick W. Miller, 40, object count 5, right? So I created 5 different people. Corey Lee S. Miller, 36, Katrina Powell, 35, Lois Miller, 59, and then Kyle V. Miller, there's his relationships, right? He has a parent, Rick Miller, another parent, Corey Lee S. Miller. He has a father, a mother, an aunt, and a grandaunt. And then I have a child, I have Kyle Miller. I have a son, Kyle Miller. Corey Lee has a child, Kyle Miller. She has a son. And then Katrina has a nephew, and Lois has a grandnephew. All right. So what's the point of this? The point is, how do you define a method, right? So I just wanted to make method definition a little bit fun. So let's go back to the code. We're going to go back to person. So we have, when you create a method, right, you name the method, use the def keyword, add relationship. So again, that's what I was trying to say, the difference between properties. A property looks like a method, right? But the semantics are different. When you assign a value to a property, you use like you're assigning the value to to like an attribute, right? That's how Python changes that's what meant by change the semantics. All right. All right. I think that's it for this example. Let's go back to the book. Okay, so that's it. Methods. Okay, it's not rocket science, really. Like I say, everything that you learn about functions applies to methods. The methods are defined as part of a class. They require the self attribute because self is how it figures out what data it's working that, the method is going to work on, right? Which object, and the object points to the data. So that is that's the importance of the self keyword, right? And that's it pretty much for this chapter and this video, classes part 2. Okay. I recommend as skill building exercise, you do some research on solid design principles, right? History of object-oriented programming, dive deeper into Python support for object-oriented programming. Obviously, the next several chapters, let's do a peek ahead, right, as what's coming down the pike. So I take a look at the chapters. We've got, we are just finished up chapter 17. So in chapter 18, we'll talk about inheritance. In chapter 19, well-behaved objects. And then we'll get into network programming, and client-server programming. All right. Hope you enjoyed this video. Hope you found it helpful. And I'll see you in the next video.